All right, we have a little list and we want to just find something in the list. Now, one of the things we're going to talk a lot about is patterns, and one of those patterns is for finding something in the list. They talk about this at the beginning of chapter 4, is you can say for X in L. L is the list up here, and you have a colon. That's an important piece. And we'll say something like if X equals 2, another colon, you notice that this is indented right here, print, and I'll just do an F double quote, X equals like so. Now I hope I got the syntax right. But we're actually going to go and type this in and run it, so we'll find out if I got the syntax right. And if I didn't, that's a mistake. That's not a bad thing. So we do this, and as we're going through the list, now we could have a big long list, but we find out if there is a case where X is in the list. Now, this is kind of a silly thing because we can look at the list and see it, but if the list has 2 million things in it, it becomes a lot less silly. Or if, say, you are looking for a particular genetic pattern inside the human genome, and there are 2 billion coding letters, and you'd like to know if this person has this pattern that means that they're going to develop cystic fibrosis. Suddenly, the meaning of, is this pattern there, really important? Now, this kind of a pattern is a really common thing, where we're going to go through one at a time in a list, and we're going to see if we've got something, and we're going to do something with it. Now, for the homework, we're going to have a slightly different pattern. We're going to say, we're going to take a file, we're going to read that in to the program. Our process is going to be then to process the file, which in our case, in this first version of the homework, isn't going to be much. In fact, I don't think we're going to do any processing. So we're going to kind of leave that one out. Then we're going to search it, okay, for a particular value. And if we find that value, we're going to print it out. Now, the reason I say this is because when we get to the search and print phase, that is that pattern. So we're basically going to go, okay, I'm going to search down through the list, and I'm going to get to this. I told you there is no process. I'm giving you the code for the read. So you put in the code for the read, you implement this search, and that's the first piece of the homework. Now, we're going to talk a lot about performance and how computers work, because if I'm searching through this, I'm going to do this one, and then for as many as there are. Okay? And we have in computer science a thing called big O notation, and that's big order n, because we say that there's n things in that list, and it's going to go loop through n things. Now, the second part of the homework, we're going to make it so that it's faster than this. But that's not horrible performance for a lot of stuff. And if n is small, then it's pretty good performance. I was working at US West, which was purchased by Sprint and is now some other phone company. But if you have a landline, you're using US West service. And my manager, who is a business person, and I think business people have a lot of skills when it comes to business, but she didn't really have much skills when it came to computer stuff, found out that I had put in linear search loops in my code. And she wanted me to use better algorithms in my code, so she specified that I was supposed to use published algorithms for things. And I went, okay, all right, I will replace my linear search, order n, and there was only like 10 items I'm searching through, with a published algorithm. And there's this famous computer scientist by the name of Dijkstra. He implemented one of the first 2 programming languages, a thing called Fortran, and one of the algorithms he described in a published paper, if you go back far enough, is the L algorithm. L is for linear, and that is this algorithm. Start at the beginning, go through it one at a time, and search it and find it. So I put in that I had replaced my algorithms with the L algorithm. She was happy. I didn't do anything. And I certainly didn't take time to make this faster because when you're searching through 10 things, it just doesn't make much difference. Now, our read, and we're going to get to this, reads in a list of tuples. And that list of tuples is what we're going to search, which means our search is a little bit more specific. Because what we're going to look up is the tuple is a combination of a name and a phone number. And we're going to look for names. We're going to print out both name and phone number. So the print is basically the same. We're going to say, if we found it, this is what it is. But when we go searching it, we're not searching for both the name and phone number. The piece of data we don't have is the phone number. So we're going to search through it, and we're going to search for names, and we're going to print out phone numbers. And there are going to be some steps. First, we're going to do it this way, the slow way. I've got a big list of phone numbers. They're fake phone numbers except for mine. And we're going to do it that way. Then we're going to turn around and we're going to do it with a bigger set. So we're going to test on a little set. We're going to test it on a big set. Now, that's going to give us one way. Then we're going to go in and we're going to take this piece, process, and we're going to implement a sort. Okay, we're going to sort it by names, and we're going to change the search to be faster. And the combination of sorting and searching on sorted data is a really common thing. This is what databases do. When you log into the University of Wyoming, it doesn't go searching through all 12,000, 15,000 accounts to find your account to find out if your password matches. Not using this algorithm. It uses a database that has the data already sorted, and it goes and finds your information quickly. So instead of doing it slowly, it does it quickly. All right, let's go give this a spin in our visualizer, and then we'll take a closer look at how we're going to make this not order n, but much faster.